Okay. Have you ever wondered when um, a heart is removed from an animal, it will continue to beat? Okay, the heart will continue to beat. Why? Why is that so? In this presentation, we want to answer that question. We want to see, first of all, how does the heart generate its contractions, and how do these contractions actually spread to all parts of the heart, and then what are the different factors that actually influence the the pumping of blood or the heartbeat, basically. What are the factors that influence the rate of heartbeat? So let's go into that. In humans, we talk about what we call double saturation. With this, we emphasize the fact that the heart pumps blood to the lungs, and then from the lungs to the heart again, and then to the rest of the parts of the body. That's why we call it double saturation. So we have systemic saturation. Uh, we have systemic saturation, and then we have pulmonary saturation. So therefore, that's why we call the saturation in humans double saturation. Okay, so um, we can explain this double saturation in parts of which parts of the body pump blood where. The left, um, the left pump, that is the left ventricle, squeezes blood out of the heart into the rest of the body parts. Okay, the rest of the body parts, and then the right pump, that is the the right ventricle, when it contracts, pushes blood to the pulmonary, to the lungs, basically. So the blood goes to the lungs for gaseous exchange. So that means that the left pump is responsible for systemic saturation, and then the right part, or the right pump, is responsible for the pulmonary saturation. So those are the two pumps. Uh, they don't really work distinctly. I mean, and they basically all works together in a synchronized. These pumps all work together in a synchronized way. It's important to emphasize that. So don't think that we have one pump here and another pump here that are not really working harmoniously in a way, and we'll see that how that is actually achieved. Then the heart is very good at pumping blood to the lungs and also to the rest of the body parts. But what happens if we have no valves? It means that some of the blood will flow back. As the heart contracts to push the blood, some blood will come back, flow back of blood, if we don't have valves in the heart. So the heart has valves to make sure that the blood flows in one direction. When there is contraction, the blood goes and doesn't come back. So those valves play that role. That means, therefore, that if you have a person who has problems with the valves, they are going to have a lot of challenges with making sure that the body receives enough blood. So that's a challenge. So we'll also see that these valves are made up of flaps. So these valves have what we call flaps, and it is because of those flaps that we have the names like tricuspid, bicuspid. You can notice the tri and you can notice the bicuspid there. So these actually, the tricuspid and the bicuspid, we can call them collectively as bicuspid valves. Bicuspid and the tricuspid valves can be collectively called the cuspid valves. Okay. The other name that we can call these valves, the atrioventricular valves. Atrioventricular valves. So that means that there are valves between the atrium. You have between one atrium and another ventricle. The other atrium and the other ventricle. Or we can say between the atria and the ventricles, just to emphasize the fact that if we are talking about the right and left atrium, we are basically the two, we are calling them atria. Okay, so the plural, if we have, this is atrium, singular, the right atria. If you're talking about the right and left, then we are talking about two. It means we need to call them atria. Okay, so we have two types of valves that are between the atria and the ventricles. The one on the right hand side is what we call the tricuspid valve. So it is between the right atrium and the right ventricle. The bicuspid valve between the left atrium and the left ventricle. Okay. And then we have other valves, the semilunar valves. These one are two, the aortic valve and the pulmonary semilunar valve. Okay. So one leads to the aorta. The aortic valve leads to the aorta, and then the pulmonary semilunar valves lead to a pulmonary artery. Why do I emphasize this? Such that you will be able to emphasize or to correlate the heart sounds. We have the la and the da heart sounds. So la is because of the closure of which valve, da is because of closure of which valve. Is something that we will discover. So generally, how the heart contracts, you need to know the mechanics. Okay, the mechanics, especially in relation to the pressure changes that happen. The changes in pressure are the ones that result into movement or flow of blood. Okay, so starting with the atrioventricular valves, they are closed when the pressure is low. When the pressure builds up in the atria, they are forced to open, and then the blood goes into the ventricles. Okay, so when we have the pressure in the atria greater than what you have in the ventricles, then they will open. This is the first statement. Okay? They will close when the pressure down, which is down the ventricles, is higher than what you have in the artery. So the blood will go through the semilunar valves. Okay? So the semilunar valves open when the pressure in the ventricles is actually higher, such that the blood can go through the pulmonary artery and the aortic arch to go to the rest of the body parts. And the reverse is true. Okay? The reverse is true. The meaning of that is that they close if the pressure in the aortic artery is greater than what you have in the ventricular pressure.